Hey folks, we're going to take a look at some calculations for strong acids and strong bases. One of the keys to this is understanding that strong acids and strong bases 100% ionize. Okay, so remember what dissociation and ionizing means is that it's starting off as a compound and then it physically separates into separate ions. Okay, so in order to do these calculations, we have to understand that strong acids and strong bases fully or 100% ionized. So let's take a look at this first problem, and it wants to know what is the pH of a 0.050 molar chloric acid solution. I like to use something that we call the RIE method to solve these problems. And the RIE method is where you have the reaction, the initial concentration, and the ending concentration. And so we can use all of these items to find the pH. Okay, you may be asking yourself, how am I going to find the pH of that? I'm going to show you right here. Okay, let's take a look at the reaction. I know that chloric acid is HClO3. Since it's a strong acid, we're going to add in a single arrow, and that's going to dissociate into H plus ions and chlorate ions. Well, my initial concentration of HClO3 is this 0.050 molar, okay? Initially, before anything has happened, it hasn't broken up yet, okay? And it's still all one big compound. So I'm going to say that my initial concentration is 0.050 molar. Well, if it hasn't broken up yet, if everything is still together, then I don't have any hydrogen ions and I don't have any chlorate ions. At the end of the reaction, once everything has dissociated, since HClO3 is a strong acid, and since all of it is going to dissociate into H plus and ClO3, I know that I'm going to have none left over at the very end because it's all going to dissociate, right? Well, let's think about this. Let's say I have H and ClO3 that are stuck together, okay? I have one of these molecules. When this separates, I'm going to have one hydrogen and one chlorate, all right? So that means that one of these gets me one of these and one of these. It does not mean that one of these gets me half of one of these and half of one of these. So when I look at this and I see that I have 0.050 molar HClO3, this is a 1 to 1 to 1 ratio. So therefore, this value, 0.050 molar, is going to be the same right here and is going to be the same right here. Okay, so these are my concentrations. My concentration of HClO3, my concentration of H+, and my concentration of chlorate ions. It's all going to be 0.050 molar. Okay, this initially and this at the end of the reaction. So now I know I need to calculate the pH. Well, in order to calculate the pH, what do I have to know? The hydrogen ion concentration. Well, lucky for us, we've got it right here. So now, of course, I'm going to take this 0.050 molar and I'm going to do the negative log of that number, 0.050. I'm going to type that into my calculator and then I get a pH of 1.3. And that's how these problems work. Does that make sense? So let's take a look at another problem. Let me get this one erased real quick. We're going to trick it up just a little bit, okay? Oh, do I want to switch? Why not? Okay, oh, no, do that. Okay, so let's go ahead and take a look at this problem dealing with calcium hydroxide. Once again, I'm going to use my RIE method. I'm trying to find the pH, and so I'm going to start off with my reaction of CaOH2, strong base, so I'm going to get a single arrow, and that's going to dissociate into calcium ions. And how many hydroxide ions do we have here? We have 2, so this is actually going to be plus 2 OH minus. Okay, oh, now I've got a 1 to 1 to 2 ratio. So let's see how that's going to play out. I know that my initial concentration of calcium hydroxide is 0.0682 molar, and my initial concentration of these other two is 0 and 0. So now I'm going to say, well, if this is a 1 to 1 to 2 ratio, I know that it's strong base, so this is going to be 0. Okay, since I've got 1 to 1 right here, that means that this is going to be 0.0682. Well, this now is a 1 to 2 ratio. So if this is 1 to 2, I know that this concentration right here is going to be double what my initial concentration was. So when I double this, I get 0.1364. Well, remember, I'm still looking for the pH. I don't have enough information right now to find the pH, but I do have the hydroxide ion concentration. And what I can do with the hydroxide ion concentration is I can find the pOH by taking the negative log of this number. Okay, when I take the negative log of that number, I get that the pOH equals 0.865. Well, if the pOH is 0.865, I can subtract this number from 14 to get my pH, and then my pH would equal 13.1. Okay, so that is the difference between having a 1 to 1 to 2 ratio or just a 1 to 1 to 1 ratio. Okay, that's also the difference of having a base in comparison to having an acid. Okay, when you have a base, you're dealing with the hydroxide ion concentration. When you're dealing with an acid, you are using the hydrogen ion concentration. So let me get rid of some of this real quick, and then we will take a look at one more problem. Okay, so this problem gives us the opportunity to go backwards. It says, oh, excuse me, if the pH of a hydrobromic acid solution is known to be 3.2, what is the hydrogen ion concentration? So I'm going to use my RIE method again, RIE. Okay, my reaction is HBr breaks down into H plus and Br minus. Now, notice I don't know any of my concentrations. All I know is that the pH is 3.2. So what I'm going to do is I'm going to plug in my zeros because I know that this is going to end up being 0 and 0, and then at the very end this is going to be 0. So now I have these three blanks, and I need to use the information I have in the problem to solve for one of these blanks. So I know if the pH is 3.2, I can do my anti-log where I take 10 to the negative pH, which in this case is 3.2, and plug that into my calculator. When I plug that into my calculator, I get that my hydrogen ion concentration is 6.3 times 10 to the negative 4. Well, guess what? Hydrogen ion concentration is right here. 6.3 times 10 to the negative 4. So this isn't necessarily the pH of the hydrobromic acid solution, but if I want to go back to that, if I want to go back to this, I know that this is a 1 to 1 to 1 ratio, so therefore this is going to be the answer to this blank as well. Go ahead and practice with a few more of these. We're going to take a look at some more of these in class as well. I would go ahead and make sure that you can do as many of these as possible. Thanks.